This is a data-based question, and this is a calculator question. Part A is asking us to approximate the rate of change of the temperature of the T at T equals 3.5. We want to select a smallest interval as possible and an interval where we can center, where 3.5 would be the center. So we're looking for H prime of 3.5. We're going to approximate that instantaneous rate of change with an average rate of change, or we're going to approximate that slope of a tangent with the slope of a secant. We're going to use h of 5 minus h of 2 over 5 minus 2. H of 5 is 52 minus h of 2, which is 60, over 5 minus 2. We don't have to simplify. This is both our setup and our answer. This question doesn't ask for units, but if it did ask for units, the units in the numerator would be degrees Celsius, a change in temperature, and the units for the denominator would be minutes, a change in time. Part B is asking for the meaning of this 1/10 times the integral from 0 to 10 of h of t dt. So we're integrating the temperature of the T, we're dividing by the interval, then the meaning of this integral is the average temperature of the T. In degrees Celsius from T equals 0 to T equals 10 minutes as noun, units, and time. Then it says use a trapezoidal sum with 4 subintervals to estimate the value of the average temperature. So 1 subinterval is from 0 to 2, 1 subinterval is from 2 to 5, 1 subinterval is from 5 to 9, 1 subinterval from 9 to 10. So then 1/10 the integral from 0 to 10 h of t dt is approximately 1/10 times that area approximated using trapezoid. So 1/2 base 1 plus base 2 times the height plus 1/2 base 1 plus base 2 times the height, 1/2 base 1 plus base 2 times the height. And there's 4 of these trapezoids. The first base is 2, the second base is 3, the third base is 4, the last base is 1. And not bases, but heights. And then base 1 and base 2 for the first trapezoid are 66 and 60. For the second trapezoid, 60 and 52. For the third trapezoid, 52 and 44. For the last trapezoid, 44 and 43. And we don't have to simplify. So then this is our answer. Then we get to move on to part C. Part C is asking us to evaluate the integral from 0 to 10 for h prime of t dt. So this is the first fundamental theorem. We could also look at this as integration. So when I integrate h prime, I get h, and then I plug in the upper limit, and I plug in the lower limit. So the integral then of h prime dt is going to be h of 10 minus h of 0, which we're going to get from the table. H of 10 is 43. H of 0 is 66. And again, we don't have to simplify, so we can leave 43 minus 66 as our answer. And then we have to explain the meaning of this integral as well. When I integrate the rate of change, I'm going to get the amount of change. So then this integral represents the change in the temperature. The change in the temperature of the T. There's our noun. The units in degrees Celsius from T equals 0 to t equals 10 minutes. And then part D, at t equals 0, the biscuits, so now introducing biscuits into this problem, have a temperature of 100 degrees Celsius. The rate of change of the temperature is b prime of t, given by this function. And it says, figure out at time t equals 10, how much cooler are the biscuits than the tea? So integrating the rate of change of the temperature of the biscuits from 0 to 10 is going to give us b of 10 minus b of 0, where b of 0 is 100. So then b of 10 is equal to 100 plus the integral from 0 to 10 for b prime of t dt. Or we can use our calculator to evaluate that integral. So with that function stored into y1,
What?
100 plus the integral from 0 to 10 for the function that I have stored in y1, integrated with respect to x, gives me this 34.183. H of 10 is 43. We can read that from the table. And then H of 10 minus B of 10, the difference in the temperature here. (43) minus that 34.813 gives us 8.817. So then what we'd say is the biscuits are 8.817 degrees Celsius cooler. Oops. Than the tea. One point for estimating H prime of 3.5. 1 point for the meaning of that average temperature integral. 1 point for the trapezoidal sum. 1 point for the estimate for the average temperature, which means the trapezoidal sum times 1/10. 1 point for the value of the integral of h prime from 0 to 10. 1 point for the meaning. 1 point for using b prime of t as the integrand. 1 point for using b of 0 equals 100, and then 1 point for your final conclusion that the biscuits are 8.817 degrees cooler than the tea.